Today we will be going to study about this hard problem from Leetcode 2713, maximum strictly increasing cells in matrix. Let's read out the problem statement. So basically we will be given a one index m cross n matrix. We can select any cell as a starting cell. We can select this one or this one or this one, any one. So we can select any cells. We are clear at this point. So from starting cell we can move in same row or same column. Cool. We can move on this same row or the same column like this. So the row will be this and the column will be this. So basically we can move anywhere from this particular starting cells. We cannot jump diagonally or anywhere. We can go leftward, rightward, or upward or downward. So we have 4 directions where we can move it from my starting cells. So let's say we want to go to our some certain destination cell. Let's say this is 4 and it want to go this this place. So the condition is that this can move to this place only if this value should be greater than this one. Starting cell value less than destination cell. So then only we can move, because the problem says that maximum strictly increasing cells in matrix. Okay, now we are clear here. So here in this case 4 will not be able to move anywhere. So basically 4 it can visit itself only. So the answer for the 4 will be 1. Okay, let's move to the output part. So in output we have to return the maximum number of cells that we can visit, starting from any starting cells. How many particular cells we can visit. Basically cells means that we can which element we can visit, on which elements we can go. So let's say we have some inputs given. So this is 3 1 3 4, let's say. Okay, so let's say this is the matrix and the output is 2 for this. Let's say how we got let's see how we got this output as 2. So basically first I will try to figure out what is the problem statement by handling this example input. So we can pick every cell and try to find out which is the maximum cell visit I am getting from every proper cells. So let's say I am starting from 3. I can go here. No, I cannot go here because this is smaller and this is lower. We can go only in increasing cells. We cannot go here also because this is same, and this we cannot move. So the value for this 3 will be 1. And let's say we start from 1. Now 1 can move here also because the left part is greater than and down part is also greater than the current starting cells. So it can move this side or this side. Let's say it moves this side, it will reach 3 now, and at point 3 he is blocked, he cannot move anywhere. So he can move here or here. And now let's see if this guy goes here 4, so then also he will not be able to move from here because the this is lesser than that and this is lesser than that. So the value for 1 will be, it can go here and here, so the 2. Okay, so we find out this is the thing here. Okay, so for 4, let's say this is the 4 and we want to move now we cannot move from 4 because the upper part is lower than the current part. So then we cannot move, not this side also. Left part is also blocked and down part is also blocked, so we cannot move anywhere. So the value will be 1, and same goes for 3, value will be 1. So the answer will be our 2. Like this we can find the answer. Let's see another example, that is 3 1 6 -9 5 and 7. So here if you see, all the elements are unique. So this 3 and 1 and 6 -9 and 5 and 7. So basically if we start from 3, where we can move? We cannot move anywhere because the we can move, like we cannot move downwards because this is lower and this is the only one value. We cannot move just beside this 3 because this is the lower value and this is not. So coming back to where we can move in our row or the column. So this means this can go to this one directly, this can jump, because we are not told that we can move only one step, we can move any number of steps, we can repeat the process any number of times. We can go here 3 to 6, now it can go 3 to 6, and now 6, after going to 6 this can move to 7 because 7 is greater than the 6. So here it cannot move here because as we know, because this is lower and this is smaller. So 6 can go to 7. Cool. Okay, so this can move 1, 2, 3. So let's create a answer matrix for this. 3 will be 3 because 1, 2 and 3. After that it is blocked, it cannot move. Let's see 1, where 1 can move. 1 can move here also and here also. So one thing, if you see, 1 can move 3, but after 3 the same thing will repeat, 3 to 6, 7. So we can say that for 1 we will be getting 1 plus 3 right now. We can also move to 6, no problem, we can move to 6 and then 7, that will be only 3. So anyhow we are getting 4, that is maximum. So I'm eliminating that part right now. We can also go to 5, no worries, but after going to 5 we can go to 7 only. So there will be 3 bars only, so we cannot move. Okay, cool. So we got the problem statement here. What is a naive way to move from one cell to another? So let's say we calculated this is the 4 and 6 can move here only, so the 2. 7 cannot move anywhere because this is the greatest element, 1. 5 cannot move, 5 can move here, so 5 will have 2. Minus 9 is smaller than 3, so it can move to 3. Cool, it can move to 3. So basically after 3 it can go to 6 to 7. Again we can say that it will get 4. Cool. So the maximum value will be 4 and here our output is 4. So we got the answer. So after going through multiple outputs, I found one common thing. So we observe that there is one pattern. Let's say we take this one, 8615. So basically we can draw this again here, 8615. So after going through lot of problems, lot of examples, I got to know that if we start first, we will start populating for the greatest number. Let's say greatest number is 8, okay, and greatest number cannot move anywhere, so the value will be 1. And now we will go in descending order. So 6 can move to here, so value will be 1 plus 1 because it can go here and then we will get the value from here, and that will be 1 plus 1. Now 5 we can go 5, we cannot go lower values, so we will be just looking for 5. So the 5 can go 1 plus above 1, 2. Okay, and now comes part 1. So 1 can go to 5. So 5 has given us 3, so 1 plus 3. So the answer will be 4. Likewise, we can solve any number of problems here. Let's say we want to solve for this one, 8, 6, 9, 1, 5, minus 3, 9, 3, 7. So 0, 1, 2, 0, 1, 2. Alright, so we will start from 9. 9 will give us 1. Now we will go to 8. 8 will just go to 9 basically. It will give us 1 plus 1. It will be 2 only. And here is again 9. So 9, this one, 1. So after that there is 7. So we see that in the same row, if this is 1, it can move to 9 only. If there is no such 9, then it cannot move anywhere. It can move this side. If there is such no 9 here, then its value will be 1. But here we have greater value, So we can say 7 can move to 9. Cool. And 7 can move to 9. So he will move only one place only. So basically after going, it will just get us 1 plus 1, that will be 2. Now let's go to 6. 6, let's say we just update this 2. This is 2 only. Okay, I think this is visible. Cool. Let's go to 6. See, 6 can move to its greater element. So if we see in this row and this column, there is no filling of that any values for 6. So 6 can move here only. So 6 will move to 8, and 8 directly will move to 9. So 1, 2 and 3. By calculation we can say we will just take the 2 and add the 1 plus, because the maximum of this or maximum of this 1 plus 2, that will be 3. Now we go to 5. 5 can move here or here. Let's say 5 have this. Only 5 is matching with this guy. So let's say 5 goes to 6, 6 will go to 8, 8 will go to 9. So the value will be 4. So we can just directly say that the maximum is 3 in every direction. So it will be 1 plus 3, that is 4. Cool. Now we solve for 4. Let's solve for 3. So the 3, again 3, the maximum. Here if you see the maximum to 1, 4. 4 is the maximum. 4 is the maximum, so it can move 5. 1 plus 4. Again for 1, 1 also, 2, 1 and 4. What is the maximum? 4. So the answer for this 5. We can calculate also. And again minus 3, 4, 1, 2. So the maximum is 4, so this will be again 5. So our answer will become 5, because in all this answer matrix we have just 5. Okay, understood. But let's calculate it manually. Minus 3, where it will go? Minus 3 can't go directly to 9. If it will go to 9 directly, then it will just get 2 value. Minus 3 and 9. 9 is the biggest value. If it will go to 7, let's say go to 7, 7 will go to 9 only, because in this row and the column only 9 is here and 9, it can go here or here. It has already given its value 2. So minus 3 to 7, 7 to 9. Like this it will go, and there will be 2. So it can go in between, minus 3 to 5. It will go minus 3 to 5, 5 will go to 6, 6 will go to 8, 8 will go to 9. So total 1, 2, 3, 4, 5. So the 5 is the answer. Cool. So we got the problem and we got a solution also how to implement this. Implementation part is still remaining, but we know the idea how to implement it. So let's start with one edge case or one important aspect of this problem, that is strictly increasing part. So if we say strictly increasing, what does this mean? So let's see this example. Here we have same values. So the same values will create a problem. Like our intuition was that we will be going from descending order manner. Okay, so let's create an answer key for this. Let's say 0, 1, 2 and 0, 1, 2. Cool. So we will start from largest value. So this 4 can move nowhere, that will be 1. Now 3, here 3 is there. We have 2 3s, we can take any one, not a problem. Let's take this 3 upper one. So this 3 can move only here, so that will be 2, or we say 1 plus 1, that will be 2. And this 3 again will move here only, so this 2. Now comes part 2. So the 2 can take this maximum and plus 1, that will be 3. And this 2 again, this has nothing here, just 1 is the maximum, no upper bound or not lower bound, we just have 1. So 1 plus 1, that will be 2 for this guy. Now comes part 1. 1 has this one, 2 and 2 here also, in this row and this column. So this column and this row. So 2 or 2, this one, maximum 3. This can get 3. Cool. And let's say we fill this one, 1. So if we fill this one, we will see that 3 is the maximum. 3 is the maximum, and if we fill that 3, 1, 4, that will be 4. Cool. Because this here we are getting 1, 2, and here we are getting 3, so 3 is the maximum, so 3 plus 1, that will be 4. Now comes part 1. Now 1 will also say that this in this column and in this row, what is the maximum where we can add our value. So here 3, 2, 3 and 4, 3, 4. So the 4 is the maximum in this column, and in this row 3 is the maximum. So it will take 4 and it will add up 5. Now that is the trick part. So this 5, which is this 5, this is not the correct answer for 1, because 1, if you see and go trace one by one, 1 can move 3, okay, 3 can move 4, that's it. Cannot move to any other portion, that will be the 3, its value will be 3. But here we are giving 5 on the basis of our intuition. Because of this value, this 1 can move to the 4 cells. How? 1 to 2, 2 to 3, 3 to 4. 4 cells. That is correct for him. But we are considering this for our answer for this one, because both are the same. If both are the same, this cannot move here. If we are considering this means that we are moving here, and then we are moving here, and then moving, then we are getting 5. But we are strictly increasing. That is the trick. So we cannot move here. So in these scenarios, what we will do? In these scenarios, we will just skip. We will not select those values in our maximum calculation which are having same values as of now. So we will not consider this. We will just consider this below 1, and that's it. This and 2, because this is also same. We will not consider this in our answer. We will just consider this and this. So the trickiest part here is like how the implementation will be done for this thing. Okay. So we will figure it out how we will do that. First, let's build the solution for unique pairs, unique traversal. So that will be unique traversal. We will build the solution for unique traversal, and from that unique traversal we will make solution for this similar part, similar numbers or same numbers. Cool. So let's start building the solution for our similar problem, where we were just visiting from increasing the higher value to lower value. We will first build the solution for this. So we will first go to higher value and fill the value for that. Then we go next higher value. We will fill the value based on the previous higher value, or the column row value, which is the maximum. Again we will check for that. If nothing will be there, so initially our answer array will be 0. See, like that it will be there. Cool. So if we have higher value, so let's say this is our answer array. Let's say 1, 5, 8, 2, 4, 6, minus 3, 1, 4, something like that. So when we go to 8, we will see the maximum in this row and this column. Cool. So here the maximum is 0 in both sides. So we will just add in here, what we will add, 1 plus max of all row values and all column values into this. So our main formula will be this one only. So let's say we want to fill this, and this is at second column and 0th row. Okay, so this 8, let's say this 8 is at 0 row 2 column. So our value will be 1 plus max of this row, this 0th row, maximum of all 0th row value, comma maximum of our 2th column, and that we will fill in here. And now we have to fill for 6. We will go to 6 here, and again for 6, let's say 6 is this one, column row 1 column 2, so 1 and 2. So again this formula will be same, but here we will just add this 1 row and second column, second column. So that's how we will implement our solution. Let's build solution for increasing order and where we have only unique values. We will assume we will having unique values, then we will fix that duplicate parts. Understood? So for now we will be creating a solution for that. So let's say we have this values 158, so we will just basically create initialize an array list, and in array list we will having integer array, which integer array will be containing 3 values. So first 3 values, so first value is this 8, and then we will say that it will contain row number and the column number 2. So that's how we will note down our all those values for all those matrices in this array list, which will take integer as an parameter for this. Cool. So let's create that array list. Let's iterate through. Iteration will just look like this. We will go from I to n, and then again we will go from j to m, and then we will just add our array dot add, and we will just do this thing. We will just, let's say the matrix is I comma ij, and I will be our value and j will be value. That's it. This will complete our all the traversal. So here we will just do this traversal and we will get all those values. Let's take a smaller matrix, so we will show how our array list will look. So for 4 it will be looking like something 4 comma 0 comma 1, and then 3 comma 0 comma 0, and then 2 comma 1 comma 1, and then 1 comma 0 comma 1. Like this it will look. Okay, so we will sort this array based on the integer value. We will sort this. Okay, and let's start building another part. We have sorted the array, and we have populated row And the second part is here we have sorted the array, and now if we see here, we have sorted, we have populated the array. Now is the part where we have to define two more integer array, let's say of size n and m, so that will store our maximum values. Max row will be integer array, and that will create, that will store our all those, this like for all the rows we will be having some maximum, let's say this row, and this row. So for this row the maximum value is 3, this row the maximum value is 4, this row the maximum value is 3, right? So we will initialize that, because we need to later populate regarding this row and this column according to this, like we will take the value for this 40, and we will having our row, this max row will have size, let's say for this it will be having size 2, so it will be having 0, 0 value. So when it comes here and it will check 0, what is the value here, it is 0, and same goes for max column, it will be 0, 0, so it will check 0, 0 is the maximum, and then it will calculate our that for 0 column and 0 row, 0 row and 0 column it will calculate it, or 0 row or 1 column it will calculate 0 and 0, the max will be 0 and 1 plus this will be 1 plus this. So after getting this 8, we will populate our value 1, where we will populate in row also and the column also, because this 8 belongs to row and column both, right? So it will belongs to, let's say 0 and 2. So 0th row will be updated with 1, and column 2, let's say we don't have column 2, let's assume this is 1 column, and we will update this also with the calculated value from here. Here we have calculated, we'll just update for those details. Same for goes here, same goes here. We will iterate from downward direction, and then we will update the values in our answer matrix. Cool. So we will define our max column like this. Max column, that will be new int, and that size will be m, and n will be rows, and this will be column. Okay, so let's start building the solution for this. So the solution for this will look just basically, we will iterate through our array list iteration. Let's say we start from I is equal to 0. Alright, we will start from I is equal to 0, and we will go till I less than what our array dot size. So we have initialized int I is equal to 0, and we have initialized, let's say, while I less than array dot size. So this will be the case here, it will go in this condition while I is less than array dot size. So let's bring one example here, so that we will be able to fill out those things. Like earlier we have this 401, correct, and then 300, and then 211, and then 101, something like that. If you can see that, so this will be like, so the 4 will come first of all. So we need to define certain things here. So basically so here we will just get that I first, and that will be, let's say, current int. Okay, let's define it properly. Current is equal to this dot get I. Okay, here we will come here and the loop starts here, and now we will calculate our value for that, which we set here. That will be 1 plus max of nothing else. We will just do what? We will having max row and max column. So max row comma this current 0. Current 0 will give us value, current 1 will give us row, and current 2 will give us column. So we will also define r is equal to cur1, c is equal to cur of 2. So we will not put like this. Let's again define this. This is not looking cool. So while I less than air dot size, so and then int cur is equal to air dot get I, and then we will be having r is equal to cur of 1, and c will be having cur of 2, and then we will calculate value. We'll name it a value 1 plus max of max row, and that will be r because we are treating row. So and max column, that will be c. Here we are correctly doing all those things. So after doing this, we will just we will update it this val, and now we have to max answer which we are going to return. So that will be 1. We can visit one cell at most, so 1 can be our minimum. So maximum we have to find it, so we have assigned with the minimum 1, so that will be 1 basically here. So and now we have decided that we will update our row and column after finding the value in max row and max column. Here if we see, max row and max column was shown like that we will update it here, because if we go to 0th thing and we found that initially it will be everything 0 like this, everything 0. So 0 plus 0, that will be the maximum max of 0, and 0 will be 0 plus 1, that will be this one. And then we will update our 0, because this row will have the maximum of 1 and this column will have maximum of 1, and we just want to check our maximum value in our row for any value, and the maximum in a column. So based on that we will calculate for our current value. So we will update it here. Okay, so we will update this also. Max row of r is equal to that will be max of max row itself, it will get first and then val. Now same goes for max column c, that will be max of max column c and val. Alright, so This will be the logic for here. Now we will also maximize our answer to get in n. So max of answer comma this value. So this will be the this just 1 2 3 4 5 6 7 8 line of code is enough to give the answer. We will just return the answer. That's it. And this is hard problem, and we are returning in 8 line of code. So but the problem will not remain in 8 line, because we have just calculated for when all the number will be unique. When all the number will be unique, then this is enough. But here the case is different. We have seen the scenario where we cannot implement this because we have something same values in the same row and the same column. We cannot take them. If you remember correctly, last time we have one example, we gone through that here, like we gone through that, and we given 5. That was incorrect. That was totally incorrect. So later we found out that we will not compare with the 1, we will compare with the 2 or the 3 in the same row. We will not compare those values which are having same numbers. So basically at this point of the time we need to think of a solution, how we can implement that in this thing, in this whole code, that we will skip this and take the maximum only for these parts. So that is not a very tough part here. We can do it. We have certain ways that we can do that. So basically one way which we can do that, we will not directly update this max row and max column, because for the same scenario we will not do this, because if we do that, then we will land into this wrong answer, because we will be directly updating according to the based on the previous value, and the previous value, if it is same, then that's a problem. So we will directly not updating this. We will be updating until unless our same scenario get ends. We will go in this loop, and where we will just compare with 1 2 1 3, here 1 4 and nothing 1 2, and for here we will compare with 2 and 3. Here we will compare with 3 and 2. We will not compare with these guys. We will not compare with these guys because they are same. So to implement that, we need to think of a solution. So basically this part of the code is correct only. Now we have to make this I as a previous, because the previous will only define as if that was same or not, and we have to define one more variable. So this piece of code, let's say this piece of code is P. Let's say piece of code, this POC. So our we will, so like we define this int I is equal to 0. So while I less than add dot size, this will be same only. Now this piece of code will remain same. Now we will define one more variable that will be measuring the current value from the array, and based on that we will be checking if the previous was different or not. So let's say we will just point to the I only, because that is the current only. So we will check this condition. If So so first of all this will be the same, and now we will check, or we will apply a while loop, and that while loop says that j first base condition less than array dot size, because we will be going to increase until and unless we are having same values. That is the condition here. So add dot get j 0 equal to add dot get I 0. I think that is not visible. That's okay. This is 0 itself. So we are comparing with I0 and J0. So if both are same, so in first scenario, if they will not be same and that is pointing to 0, this will also point to 0, so we will get one condition where J will move further in that scenario. So for that scenario we have to fill this way, but if that will be greater than 1, then that's a problem. If it is equal to 1, j minus I equal to 1, then we are in unique cases. Previous one was different, current one is different from previous. But if we greater than 1, so it means we have landed in the situations where there are multiple values, this 1 and 1. So we will just put a if condition. If j minus I is equal to 1, that means we have landed into this piece of code. We will just implement this piece of code, nothing else. That's it, this piece of code. Okay, if that is the case, then if that is not the case, then what will happen? Then we have to define these max row and max column, the max row and the max column again, but in a temporary form. So let's define this also again, and that will be the same temp row, but these are only for counting these 1 against this 2 and this 3, and this 1 against 4 and this 2, and this one for 3 and 2, and this one for 2 and 3. We will not be counting this one or this one or this one, because we will be comparing with only those guys. So we will be comparing with only those guys. So let's start for in, because we will be moving to I to j, because till I to j we have same values itself. So let's say this 1, 0, 0, and this 1, 0, 2, and then this 1, 1, 2, and then this 1, 2, 0. So let's say we land into this. So how many? 1, 2, 3, 4. So we will iterate from I, because I is there at initial position only, this one, and after that we, for this scene, we have done j plus plus. So j has moved till 5, because 0 was that was same, 0 this was same with the I, so count increases to 1, again 2, 3, 4, this moved to 4. Okay, so we will start from k equal to I, k less than j, and k plus plus. Okay, now we will again implement the same thing. But here is the catch. This piece of code, let's say this and this, and we are calculating well till this. Let's say we have temp POC. This piece of code, let's say this is temp POC. This will be same for this also. We will calculate, because max row we will not update. This part we will not update, but we will calculate on the basis of previous different value, that will be 3. But we will not update, because if we will update, we will just land into wrong condition where we will return 5. That is wrong. That is wrong. So we will just do these things. So here we will just call our temp POC block of code till here. Now we have created 2 temporary arrays, and I'm looking for those. Yeah, this is temp row, and this here we have the column. Okay, cool. So the temp, let's clear this up and go to another page. Okay, so we will again so I have written the whole code again. So basically earlier we have this POC code where we will be just getting the answer if unique value was there. So we will just getting the whole thing like this one 300211, and then we are taking out the row value and the column value, this one, and then we are calculating well. So this is temp POC. This whole structure of code, this 3-4 line is temp POC. So here if j minus I is equal to 1, we will be into this whole thing, we will get the answer directly. If that is not the case, then we are coming here, we are creating temporary row, temporary column. Cool. And after that we will iterate from k is equal to I to k is to j, because if it was greater than 1 and all those values were different. So if I remember correctly, this was the pattern, something like that. So this was the different. So we will land in this condition 1 2 3 4. So we don't want to push the values directly into max row and max column. So we will be basically adding in t row and t column, and then after comparing all those things, so let's say we are adding in temp row. So temp row will check if it is maximum or not, then it will fill with the value which we have calculated. Okay, so this will be the case, and again here t row c is equal to math dot max, and t again this is t column, and this will be c comma val. This is the same only, just that we have created in a loop where we will just compare with the newly created. Every time if certain like this 3 3 came, then 3 3 will maximize its own sub row or sub columns. I will show you in some time how the data is getting populated in that manner also. So until then, let's focus on this, and answer is equal to math dot max answer compare. Now after finally comparing with the previous value, this val is getting calculated in this manner. Val will be calculated according to max row and max column. That will not change. The only thing will change, that temporary row and temporary column filling will happen based on that val, which was the original max row and max column, because we will be comparing with different value. We will not be comparing with current value. If we do this thing, then it will just overwrite it for it. So that's why we are not doing it, and we are creating different array which will compute based on the original different value previously. So there is an intuition behind that part. We will understand it in some time. Okay, so this will be done. Then when this for loop will get closed, then we will use this t row, temporary row and temporary column filling into our original max row and max column. How we will do? We will just do nothing. We will just iterate over this t row thing, and this thing, what we say, we will just iterate till 0 to n for row part, and we will just update our max row, and let's say it is iterating using variable p. Max row p is equal to that again max. The max, we will take max row p comma t row p. Same goes for column, and 0 to m. Max column p is equal to max of max column p comma t column p. And this whole while loop, one more thing is remaining, that we will have to increase this I, and we have again initialized j with the I, so that again initialize I with the j, because I is in previous value and j has increased much more. So we will just initialize I is equal to j, and this loop will get closed, and we will return the answer. That's it. This is the code. Okay, so let's understand how we have populated the same thing. So here our rough work is there. I'm sure you will not understand with this thing, so I need to again create that particular matrix. Okay, so here it was there. So I was doing some work here. Let's try to understand in a different fresh page, or we can utilize that, because we have to see the code also in that case. So what I was doing is 1 2 1 3 4 1 and 1 0 7. So basically first condition will come 7 2 2, correct? That 7 2 2 will come here. So 7 2 2, in this case row is 2, column is 2, value will be 1. Okay, so this will be the case, because initially in row 2 and column 2 everything is 0, so the value will be 1. We will update this row and column with like this. Now again 4 1 1 came in 1 1, so that was 2, sorry, this one was that. So this will get updated, and here it will be 1 and here it will be 1. Cool. So for this one, and for 1 1 we will update this one, correct? Now 3 1 0, so this one, this is 1 and 0, so 1th row and 0th column, this one. So we will, row is 1. If row is 1, what is the maximum? Row is 1, maximum is 1, and 0 is column. This 1 0 max is 1, and 1 plus 1, that will be 2. So again we will initialize row and column. So in the 1 row we will update it 0 to 1, and column will get updated with 2 1 comma 1. Now we go to 201. Now 201, again we will look into this. So 0 row and column is 1. 0 2, what is the maximum? 2, and where 0 maximum 2 is the maximum. 2 plus 1 3. We will update in 0 and 1. 0 row we will update 3 2 1, and column is 1. So column is 1, so we will update here. Okay, so we will 0 and 1, that was, so 0 and 1, that will be 2 only, so we will just update with 2, not 3, and column will be 2 2 and 1. Now our condition come here in this case. So let's understand very carefully here. So 1 0 0. So first thing it says 1 0 0. So we will not directly go. We will create our T row, T column. We will calculate our value also. Our value will be for 0 0 2 2. Value is 3. Value is 3. Correct. Now we will, here value is 3 2 2. Max is 2 plus 1 3. Now we will just populate our this empty value. These will be, let's say, TR and TC. That will be initially 0 0 0, and this will be 0 0 0. Correct. Now we come into 0 0 condition. We will maximize our T row R and val. Our R is 0 0, both are 0 0, and value is 3. So we will update this. So TR will become 3 comma 0 comma 0. TC will become 3 comma 0 comma 0. Cool. Now we come in this part 102. Our value is already calculated. Not already calculated. Again we have to calculate value based on the max row. Max row is this one. So 0 comma 2. 0 is this 2 and 2 is this 1. So the maximum again is 3. So maximum again is the 3. Then we will update 0 for 0 and 2 in this. 0 here, 2 here. So TR will be again 3 comma 0, because we are maximizing. It was 3, maximum is 3, so we will just put 3 3, maximum is 0. 3, sorry. And TC will become 3 comma 0 comma 3, because we are updating second one. Now the scenarios come for 1 and 2. Now 1 and 2, this value is not changing, this is changing. 1, we come to 1 here, this is 2, and 2 is 1. So again maximum is 3, value is 3, and we will update here. So our TR will become 3, here 1 will become 3 and 0, and TC will become, again we have to update 2, that is already there, that's it. And 112 is done. Now the case is 120. 120. See, here is the case, main case. So last case. So 20, and in the base of 2 is this one, and 0 is this one. Maximum is again value goes to 3. Value goes to 3, and we will go to 2. We will update this one and then this one. This is already 3. So our final TR and TC will look like this: 3 comma 3 comma 3. TC will become 3 comma 0 comma 3. Now we got the final value from these all ones, and that also makes sense because we are comparing with the maximum one, not the previous one. Okay, and after this we will just populate in our max row column and max column. So we will max populate only. So here if you see 333 and 303, and here our maximum is 221 and 221. So if we populate again, so our maximum will become 3 comma 3 comma 3, and this will become 3 comma 2 comma 3. So we will also utilize not touched cells from the previous different values. So this will become new maximum 333 and 323. On the basis of that, we will be just calculated. So here last case was there 0 to 1, and 0 to 1 fall under this scenario. And if we say 0 to 1 like POC scenario, so the value for the 0 to 1 will be 2 and 1, 3 comma 3, that will be 4, and we will update our maximum directly, and we will update this 2, 3 comma 3 comma 4, and we will update this 1, sorry, equal, this was 3 comma 4 comma 3. So the answer will become 4. For which question? For this one, 1 2 1 3 4 1 1 0 7, because this 0 only have the power to go at least 4 scenarios. Let's see how. 0 to 1 it goes, it cannot go any other way other than 3. It can go to 3, it can go to 4. After that, nothing. There is only 4 traversal this can do. 4 cannot go to 7, 4 is blocked here. 1 can go to 2, 2 get to 4, 4 cannot go anywhere. Again we 3 conversions, and now 1 again, 1 goes to 4, again 4 is blocked here. Again for 1 goes to 3, 3 goes to 4, again blocked here. Like that we got the answer also. If you see 3 3 3, only 4 is coming for this part, which is I think correct only. If we see correctly, so 1 2 and 2 is going to 4, we are getting something from here. So this 0 is going 0 1 3 4, and then this 4 is blocked. 3 can go to 4, that's it. 1 can go to 2, 2 can go to 4, 4 is blocked, and we will go nothing, never. So 0 is giving us the maximum value. Okay, so we can go to 1 comma 3, yeah, okay, 2 4 0 1 comma 7, we can go to 0 comma 1 1 comma 3 comma 4, and then 7 we cannot land it here. Yeah, so 0 is giving us 4, so the value will be 4. So this 4 is the, and this 4 is the maximum. Column is 2, column is 1, and row is 2. That's why we are getting 2 values here, 4 and 4, because of the column and the row. So our answer will be 4. So this is the code basically. POC will be same. POC I have saved. This will be the POC. Our main logic lies here. We will just update the other values. For same, we will just iterate it. This is the answer. I think we are clear on this problem. We have solved a lot much here. So for maximum string increasing cells in matrix, I have explained this solution properly, and this was not a hard problem. We can say that was medium. Just only the part was that unique one. Unique cases was somewhat tricky, but we got the solution anyhow. Not a problem. Let's end this video, and hope you like it, and keep supporting us to make this happen. The proper explanation will happen like that. Keep supporting us, keep subscribing, and keep sharing. Thank you.